Hi, it's Terry Dennery of the MathWorks. So this could be another one of these preview videos. And so there are a fair number of things that we need to do, and I think it's better just to kind of show you what it looks like at the end, and then we'll kind of head towards that target. And so, anyways, you'll notice I got a lot of measurements in here, and we'll kind of get to those. I think it's better to look at the animation right now. All right, and so we've been seeing this. We know at 10 seconds it will launch and it takes off. And so I'm going to bring you to 107 seconds. Let's rescale the window. We see it. I'm going to reduce the size a little bit. Okay, just so that we can kind of see it go up and arrive at 2,000 meters. So at 2,000 meters, they'll hold this position for about 10 seconds, and at 120 seconds, we'll see it begin the rotation of 5 degrees, which will kind of launch it in the X direction. And there we go. All right, and so I want to show you the overall trajectory, at least with regard to rotation, is shown right here. And so we just saw the first rotation of 5 degrees, and then we hold that position for about 10 seconds, and then we reduce it 5, and then we run it flat, but flat having all the momentum generated by this kind of positive pulse right here. And so then we basically stop it with the negative pulse here, which ultimately leads to rotating it in the opposite direction. And so it'll be 5 degrees on the rotation of that as well. All right. So this is kind of what the pilot's doing. The pilot's kind of operating the stick and essentially choosing the orientation of the vehicle. And so the block that really represents that, I called it pilot, right? And we send it in now, and you'll see it's got essentially a PVA data capture, right? And so anyways, this is kind of how we use it, right? So I zoom up here, right? This PVA comes in here. And we take that third component, which we know to be acceleration, and we multiply it by the inertia, and that'll give us torque. I call it torque Y. All right. Now we also use the angle, so I take that first position too, and we'll kind of see that in a moment, how that works. All right, so torque comes out of this, and in this block we convert torque into essentially the thrust adjustments that are available through that port and that port for XP and XN. All right. And this is actually quite a simple calculation. Is that they have to be equal in magnitude and opposite in sign for them not to overall impact that vertical thrust that we had set up earlier, right? And so the way that torque, of course, becomes thrust, at least these two thrusts, is dividing it by the moment arm. And you might recall that we set up these two bodies called beam X and beam Y. We defined them in our early videos to be 5 meters long. Right. Now that angle is used here because as we rotate the vehicle, we've just deprecated the thrust that's acting vertically, which is very important because it's still operating against gravity to hold the vehicle up. Right. And so when we rotate, we actually need to increase our thrust. And that's where this angle goes, is for that calculation. Right. And so it's essentially, if it's running flat, tangent of that angle is 0. But as it begins to rotate, we're going to get what I'd call an X component. That X component will be that tangent scaled by the vertical thrust. And so then if we take those two components and square them, add them, and then take the square root, that's now our overall thrust calculation. All right. And just to kind of show it all works pretty well, is you'll see that our vertical position is dead on, as we see here. Again, reminding you, if I just see a simple blue line, that means that the blue line is on top of the yellow line. It means that my measurement's right on top of my command, right? And that's how we know we did so well on orienting the vehicle. And you'll see that all of it works pretty well. That little simple rotation led to a 500 meter movement translation in the X direction. And we get a little bit of drift in Y. It's about 2 meters in magnitude, but that's a pretty small number compared to the overall movement in X, which is 500 meters. So anyways, I'd say I'm pretty happy with where we ended up with this controller. And the next video, we'll kind of dive in and kind of show how we got here. Anyways, thank you.